Sir Isaac Newton, January 4, 1643 March 31, 1727, was a superstar in the fields of physics, mathematics, and astronomy, even in his own time. He held the prestigious position of Lucasian Professor of Mathematics at the University of Cambridge in England, a role later occupied, centuries later, by Stephen Hawking. Newton formulated several laws of motion and some of the most influential mathematical principles to this day. His discoveries have been used by scientists to explain the workings of the universe. Galileo's influence. Newton was born in 1642 in a nobleman's house in Lincolnshire, England. His father had passed away 2 months before his birth. When Newton was 3 years old, his mother remarried and he lived with his grandmother. Not long after Newton's birth, Galileo, one of the greatest scientists of all time, had died. Galileo had proven that planets revolve around the sun, not the Earth as people believed at that time. Newton was deeply intrigued by Galileo's discoveries and those of other inventors. Newton thought the universe operated like a machine, governed by some simple laws. Like Galileo, he realized that mathematics was a way to explain and prove these laws. 3 laws of Newton. Newton was the figure who formulated the laws of motion and gravity. These laws are mathematical formulas that explain how objects move when a force acts on them. Newton published his most famous book, Principia, in 1687 when he became a mathematics professor at Trinity College in Cambridge. In Principia, Newton explained 3 basic laws that govern how objects move. He also explained his theory of gravity, the force that causes objects to fall. Newton later used his laws to show that planets orbit the sun in oval, not circular, orbits. These 3 laws are often referred to as Newton's laws. The first law states that an object not pushed or pulled by a force will remain at rest or continue to move in a straight line at a constant speed. For example, if someone is riding a bike and jumps off before the bike stops, what happens? The bike continues to move until it falls. The tendency of an object to remain at rest or continue moving in a straight line at a constant speed is called inertia. The second law explains how a force acts on an object. Meanwhile, the third law states that if an object is pushed or pulled, it will push or pull back in the opposite direction. The significance of gravity. When most people think of Newton, his discovery of gravity is often recounted as occurring when he sat under an apple tree observing an apple fall to the ground. Watching the apple fall, Newton began thinking about a certain type of movement called gravity. Newton understood that gravity is an attractive force between 2 objects. He also understood that an object with more matter or mass exerts a greater force, attracting smaller objects towards it. This means that the Earth's large mass pulls objects towards it. That's why apples fall instead of rising, and why people don't float in the air. He also pondered whether gravity might not be limited to the Earth and objects on it. What if gravity extended to the moon and beyond? Newton then calculated the force needed to keep the moon in orbit around the Earth. He then compared it to the force that makes an apple fall. Taking into account the fact that the moon is farther from Earth and has much greater mass, he found that the forces were the same. The moon also orbits around the Earth due to the gravitational pull of this blue planet. Conflicts with other scientists. Newton moved to London in 1696 to take up the position of Warden of the Royal Mint. Over the years, he argued with Robert Hooke about who actually discovered the relationship between elliptical orbits and the inverse square law. The lengthy dispute only ended with Hooke's death in 1703. In 1705, Queen Anne knighted Newton, and thereafter he was known as Sir Isaac Newton. He continued his work, especially in the field of mathematics, leading to another dispute in 1709, this time with the German mathematician Gottfried Leibniz. The two argued about who among them discovered calculus. One reason for Newton's disputes with other scientists was his extraordinary fear of criticism. This fear led him to write his works, but then delay the publication of his brilliant articles. So other scientists ended up creating similar works. His earlier writings include De Analysis, which was not published until 1711, and Principia, 1687. Newton's publications include Optics, 1704, The Universal Arithmetic, 1707, Lections Opticae, 1729, Method of Fluxions, 1736, and Geometrical Analytica, 1779. On March 20, 1727, Newton died in a town near London. He was buried in Westminster Abbey, the first scientist to receive this honor. Legacy. Newton's calculations transformed the way people understood the universe. Before Newton, no one could explain why planets stayed in their orbits. What kept them in place? People of earlier times believed that the planets were held in place by an invisible shield. Newton then proved that they were held by the gravity of the sun, and that the force of gravity was influenced by distance and mass. Although he was not the first to understand that planetary orbits elongate in oval shapes, he was the first to explain how they work. The world-renowned scientist Isaac Newton likely died from mercury exposure. It is suspected that he directly experimented with the hazardous substance by ingesting it, leading to his death at an advanced age. Reported by Unreal Facts on Thursday, September 22, Newton was the first person to discover gravity and understand calculus. He is known as an incredibly busy scientist who never married and rarely indulged in leisure activities, completely engrossed in his work. Apart from inspiring the concept of gravity and confounding everyone with calculus, Newton apparently delved into the study of alchemy. This might be the reason behind his demise involving mercury. In 1678, Newton began experimenting with alchemy. He noted how metals tasted, including the highly toxic mercury. However, mercury was not the only substance Newton consumed during his experiments. He also tasted arsenic, gold, and tin. Although the latter three are poisonous, mercury is considered the most likely cause of his death, as well as his erratic mental behavior. Over a span of 18 months during 1692–1693, Newton was reported to have experienced mental health issues. He exhibited symptoms of depression, insomnia, loss of appetite, amnesia, and even delusions at the age of 50. For the next 34 years, Newton spent the remainder of his life dealing with dementia. Upon examining Newton's remains, a significant amount of mercury was detected, particularly in his hair. This could explain his peculiar behavior during the last 18 months of his life.